This is going to be a step-by-step process to generate G-code. We need to start with a 3D model or a drawing, and then there's two paths we can take. So it's a three-step operation. We design our part first, we generate G-code, and then we cut it out. Designing the part can be done in two different places. External software, third-party software that we do not supply. Anything that will save as a 3D step file, such as SolidWorks, Autodesk Inventor, FreeCAD, is option one, and option two is the conversational we have built into this software. So when you start it up, click the 3D button to actually go into the software where we can bring in a 3D model or create one. So again, this, like I said, there's two paths we can take now. And then they'll merge back together when we generate G-code. It's irrelevant where the pattern came from or the information came from. But to start with, we can either use the CAD input import button, and we can actually go to a location on our PC or USB drive, and there's some step files there, and we can just select the step file and open it. All right. From this point, we can add features. We cannot change features that are there. We can't get rid of this miter cut, but we can add circles or holes to it. But again, we can't change the step file. So really, 3D step file input should only be used on parts. I'm not a big fan of doing part of it in CAD and then changing it here. It really should go back to your original CAD program and change your drawing appropriately or accordingly. So from here, the path would be to just unroll this. All right. Now again, you can add holes, but bear in mind it's not going to change your step file. It's only going to change our flat pattern. So you can see that we have a flat pattern now. From here, we would give it a name. All right, and I'm going to cover that in a minute. So that's path one. That's bringing in a 3D step file. The other option we have is to actually do a conversational. So we start with fresh, clean look. We start up, we go to 3D, and we can choose which shape we want to work with. All right, when we select this, the first thing we're going to have to do is enter our dimensions. This gives you an indicator of what the dimensions are, what designations is. Side 1 is horizontal, side 2 is vertical. Wall thickness. Radius. If it is aluminum, you need to select this. It'll default the radius to 0 because there's no radius, and it creates what's called a virtual radius so that it can rotate the chuck properly and the torch doesn't gouge the side. So if it's steel, you would unselect this and enter your correct radius, which is typically double your wall thickness, but it does vary. I recommend actually measuring it. And then your material length. So I'm going to change this to 2-inch and put that at 1/4 inch, 12 inches long. And basically what you see, we bring in, it created a 3D model of that tube. Now we can go through here and run our processing. There's some other videos explaining how they work, but we define what we want to be done. We basically have, just like the last piece where we brought the 3D step file in, we have created a 3D model. We can then unroll this, and you can see that we have our flat pattern. So getting to this point is one of two different directions. We either choose to bring in a 3D step file or we conversationally create a 3D model. From this point, all the way to cutting the part out is exactly the same regardless of how you got to this flat pattern. So getting to the flat pattern, you have to choose which way you want to go. Once we're at the flat pattern, everything from this point forward is exactly the same whether you use the 3D step file or not. So the next step would be take our flat pattern that we've created, and we need to save that. So we can do different contract customer names and then contracts. All of these are located in the C:\work/cutting data directory, and you can create new folders. So I have a test customer, and my contract is going to be test. It will default to the material size name, which this is rectangular hollow section. It's 2 by 2 with an 1/8 inch wall, and its length, the L, is 12. So I will leave it at that. It tells me quickly what the material is. If you want to name it something special, you can name it whatever you want. Legs, and you just choose OK. Now we've saved, so we've done taken our 3D model or conversational, and we've generated a flat pattern from that, and we have now saved the flat pattern so that we can generate G-code. Right? Now you can go all the way back. It's saved, so the flat pattern is done. So you could go back and do some more conversational. You could go back here and import some more, however methods you want to work. So you could go and create a lot of different parts. You don't have to create a part and then go and generate G-code. You do need to create a part and generate a flat pattern. Right? Once we've done all the parts we want, or we're ready to generate code, we go to this button. And speaking of that, you don't even have to go to the 3D. If you already have stuff done, you can just start up TCS and directly go to here. All right, so this is where we're going to tell it how many we want to cut and what we want to cut. So we start by the top, choosing your power source. You only have one power source typically with our machines, and it will be set properly. You do need to pick your material. So in this case, we have mild steel or aluminum. I'm cutting this out of mild steel. You need to pick. This is your basically your location where your file is. So I saved it in my test customer and my test contract. Now you need to choose your materials. I only have one material. If, for example, I went to here and test, you can see that I have two different materials. They're not going to show up at the same because you can't nest a program that's on a different material than the other program. So going back to our example of one I did, there's 2 by 2. We named it legs. Now I can tell it the quantity that I want. And it's going to tell me my finish length, how long this item is going to be. Here we can put in our information of what we're cutting it out of. You can give it an ID number. So I could put steel 2 by 2. Steel I have 4 of them, which is irrelevant for cutting one off, but you do need to bear in mind that if you tell this to make 500 of them, you need to have enough material over here. All right, once we have that, we tell it how many we want. So let's say I want 10 of them. And now we nest it. Okay. The pro ball cuts would just be for troubleshooting or very, very warped material. Typically, we only probe at the beginning of every cut, and that is it. And then obviously the material is clamped so it doesn't move all over. If you select probe every cut, every single time it cuts, it's going to probe. It really slows stuff down. When I click nest, we're automatically going to generate G-code. It's going to ask us where to save it. So I choose nest. Now it'll always default to the last folder you worked with. So it's actually kind of handy because if you save stuff in the same place every time, it'll automatically go there. So if I go to my documents, now I can give this a name. All right, so I'm going to call it legs. All right. Choose save. You can see that I've generated a nesting solution. I can print this nesting solution out if I have a printer attached to my computer, or I can save it. Saving only saves this nesting solution. It does not generate G-code. The only thing that generates G-code is clicking nest. Okay, even if you only cut a quantity of one. So the save and print, and I need to work at making that a little more clear to the user when they're operating it. But the save and nest only applies to this information here, which is basically the list of your materials, how much you're going to use. So we can see that we're going to cut 120.5 inches of this. We're going to utilize 44.63%. We're going to have a 167.5 inch cutoff. All right, so like I said, once you click nest, you're going to get a nesting report, and you're going to get G-code. That's it. So we have brought in our 3D model or created our 3D model with the conversational. We unrolled it and saved that as a two-dimensional template. We then opened that two-dimensional template in the nesting portion, told it how many of them we wanted, and we created G-code. All right. So when I go to look at the G-code, or load it in the cutting program, you're going to see that I will have 2 programs in this case. This number may vary. It all depends on how many you told it you wanted to cut, but you will always have a minimum of 2. Legs NC, that's 1 part. So that is the conversational 2-inch by 2-inch tube that I created the miters and unrolled. That is G-code for 1 single part. Nest 1 is the first stick, okay, of steel 2x2. That was my ID of my material for these legs. Now, I told it to create 10 of these. Because I told it to create 10 of these, it only needed 1 stick. So there's only 1 nest program. So let me give an example of doing multiples. If I go back here and I tell it that I want 50 of those, and I nest, and I give it a name. Okay, now when I go here, you're going to see that I'm going to have 4 full files. Legs is still 1 single part. Nest 1 is the first 10, because I happen to know 20 will fit on here. So this is the order you would cut them in. So that's your first full stick, second full stick, third may or may not be full stick. If you need to know, you can go to the nesting report and it will show you every single stick how much. So the last one, we're only going to use 26.78%. So this particular program needs 3 sticks. If you have auto load, this will be different. This will all be in one giant program and it'll automatically load the sticks up. Without auto load, you need to open this program, load a stick up, cut it. Then you need to load your second stick and load the appropriate program. Then you need to load the third stick in your machine and cut this particular program. So that is how the file system works. It's not as confusing as it first seems. It's actually pretty easy. You just need to be aware that this is 1 single part, legs NC. This is nest 1. This is nest 2. And what it is the part number, the nest number, and then whatever you named your material. In this particular case, I called it steel 2x2. .nc because it's a numerical control file. So 1, 2, third stick. Legs is a single part. And that's it. From here, you would start your control program, which is covered in another video right here. And you would actually home your machine and load your first material and load your first program.